Welcome to Smarts Maths. Well done on going the extra mile and choosing to develop and improve yourself. Very often there's more than one way of solving a maths problem. I shall help you in discovering at least one way in which to solve each of these problems. So, here we go. Let's have a look at number 1. Number 1 says extended notation with a twist. We are so used to doing it in the same old way that this one is a little bit of a challenge. Which number is represented by 5 times 1000? And that gives 5000. So we write it down neatly. Plus 99. That one is very basic. We line up the units and the tens. Plus 1500s. 1500s is calculated like that. And 15 times 100 gives 1500. Plus the second multiple of 20. Second multiple of 20 is 20 times 2, which gives 40. Plus a half of 50. A half of 50 is calculated like that. 50 divided by 2 equals 25. Now that we have our numbers, the only thing remains to do is to add them correctly. 9 plus 5 is 14. Write the 4, carry the 1. 9 plus 1 is 10. 14, 16. Write 6, carry 1. 5 plus 1 is 6. And 5 plus 1 is 6. There we have our first answer. I'm pretty sure that you have been able to do that one correctly. Let's move on to number 2. Number 2 is a number pattern in a table. Input 1 is given and input 2 and input 3. The output of input 1 is 7. The output of input 2 is 10. And the output of input 3 is 13. To find a rule, we have to find a pattern in the outputs. So let's see, how does a 7 become a 10? It gets to a 10 by adding 3. How does a 10 become a 13? It gets to 13 by adding 3. If 3 is added from each output to the next one, our rule will definitely start like this. We multiply the input by 3. 3 is called the constant difference. So let's see how we get from 1 times 3, which is 3, to 7. We get there by adding 4. If we apply that to input 2, 2 times 3 plus 4, we get to 10. If we apply that to input 3, we get to 13. Now it is safe to say that our rule for this pattern is to multiply the input by 3 and to add 4 to get the output. Now that we have a rule, we can solve the following. For A, the output of 19 is given and we have to work out the input. If the output is given, we reverse the rule and we use the inverse operations. In other words, output, which is 19, not plus 4, minus 4, which is 15, not multiply by 3, divided by 3, equals 5. So in this case, our input is 5, and it's always safe to check that we have worked out correctly. So 5 times 3 is 15, plus 4 is 19. Yes, we have worked correctly. For B, the input of 7 is given, and in this case, we merely use our rule. 7 times 3 is 21, plus 4 is 25. So the value of B is 25. In the case of C, input of 10 is given. We apply our rule. 10 times 3 is 30, plus 4 equals 34. So there we have successfully solved number 2. Let's move on to number 3. This is a word problem, which means there are quite a number of words in the sum. But if you look at it, you will see that most of the calculations will boil down to addition and subtraction. Let's draw a picture to make it easier. At station A, 150 people get onto the train. At station B, 16 more people get onto the train and 25 people get off. So we'll add the 16 and subtract the 25. At station C, an unknown number of people gets onto the train. But when the train arrives at station D, there are 180 people on the train. So let's tackle it from the beginning. At A, there's 150 people on the train. At B, 16 people get onto the train. That gives us a total of 166. But at the same time, 25 people get off the train. So 6 minus 5 is 1. 6 minus 2 is 4. So when the train departs from B, there's 141 people on the train. When it gets to D, there's 180 people on the train. So to calculate this unknown number, we take the end number minus the number of people that's on the train when it departs from B. Do the sum and you'll see that 39 people got onto the train at C. I think this one wasn't too difficult. A lot of words, but very basic calculations. Number 4 is a bit more of a challenge. 6 people play tennis. They play singles matches, 2 children at a time. And each child plays each other child once. How many matches are played? In a case like this, I'll start by giving each child a number or a letter or a name. In this case, I'll use A, B, C, D, E, and F to represent the 6 children. Now let's start somewhere. Let's start at a specific point. A plays against B and C and D and E and F. Let's move on to B. B has already played against A, but it still needs to play against C, D, E, and F. That's B. C has already played against A and B. So C needs to play D and E and F. Let's move on to D. D has already played against A, B, and C. So D needs to play against E and against F. Let's see what the situation is regarding regarding E. E has already played against A, B, C, and E. So E needs to play against F. Let's see what the situation is regarding F. It has played A, B, C, D, and E. So all matches have already been played. Finally, we add up all the matches. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, and 1. 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 2 is 14. And 14 plus 1 is 15. So a total of 15 matches were played. I hope this makes sense to you and that you have enjoyed doing this worksheet. I hope to see you around when we do the second worksheet.